Hello everybody, we are just about at the end of another week. I hope you are doing well. This week's Think Outside the Box Thursday is going to have a little bit of something special for you. And that is, I'm giving away a prize. This is a bowl buddy. He hangs on the edge of your cereal bowl like so, and it is a little SpongeBob. And the first place winner for this week's Think Outside the Box Thursday, I'm going to put this in the mail for you on Monday. And that will be your prize if you win it. I hope you enjoyed today's lesson and take care. Balancing equation practice part 2. We're going to do problems 6 through 10 today. Problem number 6, we have PbNO3 plus HCl producing PbCl2 and HNO3. The interesting thing about this one, if you look at the polyatomic ion here, the NO3 and the NO3, the NO3 stays together, so when I balance this one, I can balance it using lead, NO3 as one thing, hydrogen, and chlorine. So again, as we did before, I'm going to put lead on this side, NO3, hydrogen, and chlorine. On the left, I have one lead, 2 NO3s, 1 H, 1 Cl. On the right, I have one lead, 1 NO3, 1 H, and 2 Cls. Well, the leads are already balanced. The NO3s are not, so I need to add a 2 to the right-hand side. I'm going to add a 2 right there. That changes the NO3s to 2, the H's to 2. So to balance on the left, I need to add a 2 right here. That changes the hydrogens to 2, the chlorines to 2, and we now have a balanced equation. Looks good. Problem number 7. BaO2 decomposes to BaO and O2. So I have a Ba and an O, a Ba and an O. Well, if I notice, I have one barium, 2 oxygens, 3 oxygens. The real problem with this one is this oxygen right here because it is a 1, meaning that I end up with an odd number on the right. So I need to balance it out by putting a 2 here to make it even. So that's going to give me 2 bariums. And be careful here, 2 times 1 is 2, plus 2 more gives me a total of 4 oxygens. And so if I add a 2 right here, that'll give me 2 bariums, 4 oxygens, and I now have a balanced equation by putting a 2 here and a 2 here. Problem number 8. Al plus H2SO4 produces Al2SO43 plus H2. Once again, this SO4 stays together. It doesn't split up. So when I balance it, I can balance aluminum, hydrogen, and SO4. Aluminum, hydrogen, and SO4. 1 aluminum, 2 hydrogens, 1 SO4 because I'm counting the whole group, 2 aluminums, 2 hydrogens, and 3 SO4s. So the first thing we know we need to do is we need to put a 3 right there. So that's going to make 6 hydrogens, 3 SO4s, and I need to put now to get my hydrogens balanced, I need to put a 3 right there. That'll give me 6 hydrogens. And a 2 right there will give me 2 aluminums, and now we have a balanced chemical equation. Again, the trick for balancing chemical equations is to change the coefficients. Number 9. This one's actually a little bit nasty, probably a little bit harder than I normally would give out to students, so if you didn't get this one, don't be too discouraged. It took me a few minutes to play with it. Carbon, hydrogen, chlorine, carbon, hydrogen, chlorine, 1 carbon, 4 hydrogen, 2 chlorine, 1 carbon, 2 hydrogen, and 4 chlorine. What makes this one particularly difficult is, if you'll notice on the right hand side, you have hydrogen and hydrogen, chlorine and chlorine. So when you have the same element in multiple places, it makes it sometimes a little bit difficult just to think through it in your head. So this one's a little bit tough. Well, the carbons are fine. Since chlorine's by itself over here, I will save it and do it last. So I need to get the hydrogens to balance. Well, I have 4 hydrogens on the left and 2 hydrogens on the right, but I don't want to put anything here because I don't want to mess up the carbon, so I'm going to change this number to make me get a total of 4 on the right. The only way to do that is to put a 3 right here, so I'll put a 3 right there. It gives me 1 hydrogen plus 3 more, gives me a total of 4. And that changes my chlorines from 4, this is 3 here, gives me a total of 6. And so I put a 3 there, that gives me a total of 6, and I now have a balanced equation. Again, that one's a little bit on the nasty side, but if you practice it or look at a couple more like that, you'd be okay. But again, I would never give one normally that hard on a test. And last but not least, number 10, we have magnesium, chlorine, sodium, and since the OH group stays together, I'll treat it as one thing, OH. So magnesium, chlorine, sodium, and OH. Again, you can treat the OH, the hydroxide, as 2 things if you want, but it's easier just to do it as 1. 1, 2, 1, and 1. Magnesium 1, 1, 1, and 2. So to balance this, I'll start with the hydroxides. I'll put a 2 right here. That makes that a 2, and that a 2. I'll put a 2 right there to balance the sodiums. That makes that a 2, that a 2, and voila. We have a balanced chemical equation. So just as a recap, when you're balancing equations, you have the reactants on the left, the products on the right, and you have to have the same number of every element on the left and on the right so that you end up with an equation that balances out. Next week, we're going to start looking at some of the mathematics of chemical equations. If you have more trouble with balancing, just again send me an email and I'll be glad to help you out. Thank you.